my name is Jordan Hawker, and I love thinking about performance. I know that maybe that's weird to say, but I think it's a really interesting problem, and it's been quite a challenge to think about that from the context of front-end applications. So I want to just take you all kind of on a journey, a little story about how we have thought about tackling this problem, and particularly how we have thought about tackling the problem of measuring performance in applications. So, why do we even care about performance in the first place? Well, ultimately, poor performance in your applications is going to impact your business metrics. The most obvious ones are things like bounce rate and conversions, right? If people come to your site and the application is slow, they're more likely to just not come back or not even engage with it in the first place. But it also impacts things like feature throughput. If you have workflows that you're counting on users completing and those workflows are slow, they're not going to get through them as quickly. They may not even complete it at all, which ultimately is going to have an impact on your revenue. And of course, from a very basic standpoint, all of us as developers are also users of applications, and I'm sure you get frustrated when you use another website and it is slow. So user satisfaction is a big part of thinking about performance. But in this case, when we started thinking about making our application faster, we didn't want to just jump in and start optimizing things. You can see lots of suggestions from people about how to optimize your applications, but at the end of the day, if you don't know what you need to optimize, then you could spend a lot of time investing in optimization work that doesn't have an impact on your bottom line. So, when we started thinking about this problem, we started looking at back-end instrumentation, right? Because that's technologies that tend to have more mature options for instrumentation. You want to have detailed information about all of your services so you can really dig in and make your APIs faster. But ultimately, you're not really getting the full picture, right? If you are just looking at what your back-end services are doing in terms of performance, you don't really understand how that's impacting the user, because today's front-end applications are not just basic HTML that's rendering what was sent from the back-end. You have a lot more complex logic going on when it comes to today's web applications. So we wanted to think about, okay, how could we actually start thinking about performance across the entire stack, and more importantly, how could we understand what is really happening in our front end? So when you think about web application performance, that's kind of a very generic term. It's kind of hard to understand what that means. But if you were to go on Google, you'd find a bunch of different metrics here, right? You'll find things like availability, throughput, efficiency, latency. All of these terms have meanings. They're all important, but they all have very specific uses. And it's hard to know which of these metrics are going to be the ones you want to focus on. Now, ultimately, you probably care about all of these in some context, depending on what your particular application needs are. But what we wanted to think about instead was what we called interactivity, or user-perceived latency. Because ultimately, we wanted to prioritize the user experience, right? So all of these other metrics are useful, but when we think about optimizing our front-end applications, we want to really focus on what the real-world performance impact of our applications are. We want to know what it is that our users are experiencing. We want to be able to understand how our performance is impacting users across multiple devices and browsers. We want to understand, how that performance varies across different regions in the globe. We want to understand network impact. We want to understand, are we constrained by the device's CPU? Are we constrained by the network itself? There are a lot of different things that you need to think about. And so ultimately, if you are tracking what the users are seeing and experiencing, what is being rendered on the page, then you can get an understanding of how your performance is reflected across your entire stack. If you're actually taking on optimization efforts, whether it's on the front end or the back end or wherever, if the metrics that you're generating are as close to the user as possible, then any optimization improvements you make will be reflected in those metrics. So we started thinking about this problem. We decided, we wanted to work against a concept that I like to call time to interactivity, which is essentially that on a web application, you have a bunch of content that's being rendered, right? But on a particular page, there's usually some primary content that the user is going there to engage with, right? You have pieces of content that they expect to be rendered in order to interact with the page, and then there's often other content that is being rendered on the page that's maybe not part of that primary content. So once the primary content is rendered, then the user perceives that the page is loaded and they start trying to interact with it. And so when we talk about rendering performance and that sort of problem, we really wanted to focus on like how do we optimize the time to the page being interactive? How do we optimize the time in which it takes the user to perceive that they can start working within the web application? Because that's really what's going to drive a lot of your metrics. So first thing we started thinking about is, okay, if we want to instrument our application, are there tools out there already that can solve this problem for us? And the answer is yes, sort of. There are a lot of third-party tools that you can use to analyze web applications. The first one that we started looking at is called PageSpeed Insights, which is a tool that Google put together. You can feed it in any public-facing URL, and it'll output an analysis against mobile and desktop. It'll give you sort of an optimization score, and it'll also give you some recommendations for like how you can improve the optimization of your website. So this is a really useful tool to just kind of do some basic tests on your app and kind of see how you're comparing against sort of broader industry metrics. Another more detailed tool that I really, really enjoy is called WebPageTest. WebPageTest.org, you can go there, again, feed it any public URL, and it'll give you this very detailed test where it scores you across a bunch of different categories. As you can see, my personal website gets an F for static content caching, so I should probably look at that. But one of the cool things about WebPageTest is that you can use it to create very specific scenarios. So you can actually customize the location that it's being tested from. You can choose what browser is being used. You can choose some of the network parameters, whether you want it to be like cable or you want it to simulate like a mobile connection or something like that. And you can actually have it run multiple test runs so that it will, in the results here, it'll show the median results to account for variance instead of just doing a single run, which is what PageSpeed Insights will do. On top of that, it also gives you this waterfall of network requests along with screenshots so you can see what your application looks like at the time for different timestamps that it took in the page. Now, both of these tools, while useful, are only really going to help you if you have a public-facing application, which I'm sure not all of you have. So what do you do if you have something that's private? Well, my favorite tool for this is Lighthouse. So Lighthouse is actually a tool that lives within the Chrome DevTools. If you were to open up DevTools and you go to the Audits tab, you can run this against any application that you have open in a tab. So you can run it against your public site. You can run it against a site that lives on your internal network. And also, importantly, you can run it against sites that you're running locally during development. Anything that you can open in the browser, you can just pull up the DevTools and run this. It'll give you a score across a number of different things: performance, accessibility, best practices, SEO. It'll give you timings below that and kind of break them down. And it'll also give you, again, more suggestions for opportunities for how you can optimize. Now, all of these tools are really useful. They're giving you a good overview of your performance. They're giving you a lot of suggestions for how you can optimize. They're giving you details that break down your network requests and all of that. But at the end of the day, there's one big problem here, which is that these external tools don't understand how single-page applications work. They don't understand the rendering process. And this is really critical because when you're thinking about building single-page applications, you have one page that is rendering a lot of potentially dynamic content, particularly if you have a site that's rich, has a lot of rich media content. You might have additional rendering going on in the page after one of these third-party tools thinks the page has done rendering. This is particularly true if you have like maybe asynchronous requests to retrieve some data, which then needs to be rendered later. It's entirely possible that these tools will consider the page done before those requests have completed, and so you kind of get this problem where the numbers that these tools output is sort of an approximation, but because they don't understand how SPAs work, it's not really going to give you accurate data, especially if you wanted to start going to something more granular, like which of my components in my application are the slowest. You know, these tools have no idea what a component is. So how are you going to get that data just from looking at these third-party tools? So we started thinking about, okay, how can we leverage framework internals in order to build out an architecture inside of our application to get this more accurate granular data? So thinking about the architectural concepts, I want to start here because I think the architecture is the same regardless of what technologies you're using. I'm going to have some suggestions later for how you could kind of approach this in different frameworks, but I think the concepts are really the same. So the first thing you want to think about is, what is your critical path, right? As I said before, every page in your app has this sort of primary content that the user is coming to engage with, and any component that renders content towards those activities you can consider to be your critical components. They're part of the critical path. You may also have in your page, what I would consider secondary components. They're also being rendered on the page, but they don't necessarily pertain to the primary activities of the page. And as such, they don't actually need to be finished rendering in order for you to consider the app interactive for the user, because the user is going to start trying to use the app whether or not these secondary components are actually loaded. So the best way to think about this is, hey, we all know the DOM is a tree, so are your apps, right? You have each of your pages, and they are nested layers of components, right? Each route or component in your app is going to have direct child components that it's rendering until eventually you reach a component that has no children and is just rendering some basic native HTML. Those would be called leaf components in our tree. Otherwise, all of these other components are essentially waiting on their children to render in order to say that they themselves are finished rendering, right? So you kind of have this tree structure where you need the leaf children to be finished rendering, and then when they're done, then their parents can say, oh, I'm now rendered because my children have finished, and so on and so forth until you reach the route level, and you can say that the whole page is rendered and is now interactive for the user. So that led us to defining a concept that we called the subscriber-reporter relationship. So a subscriber is just any component or route that is relying on child components to render. It often has complex interactions for interactivity. So you might have to wait on a network request. You might have images that are being loaded. You're going to have like a lot of different conditions where it's like, okay, in this case, I'm waiting on these three components to render, but maybe in this other case where my data is different, I'm actually loading these other two components instead. And so you kind of have to build this complex conditional to understand what it means for this particular component to be finished rendering. On the other side, you have reporters, which are just any component that's going to report its own render times. They're always going to be a child of a subscriber, so there's this dependent relationship. But because everything is a tree, most of your reporters are going to be subscribers themselves because they have their own child components, right? And so you kind of have to build this layering within your app in order to understand how everything rolls up together. So how could we actually think about implementing this, right? If you want to think about implementing this in your particular framework, I'm going to cover 4 frameworks here. You guys might be using other frameworks, and I'm not going to claim to be an expert in all of them, but I really just want to kind of give you guys the concepts for like how you could start thinking about writing this code if you wanted to architect this within your application. So the overall approach that you would use here is you want to leverage lifecycle hooks within your components to approximate the rendering process, right? So each of your components or each of your frameworks are going to have some sort of hook that's going to fire after the component has finished some sort of rendering pass. Maybe it's been inserted into the DOM. There are a bunch of different hooks depending on which technology you're using, but more or less, you want to find what is firing like right after rendering finishes. You also need your architecture to be able to account for asynchronous behavior, right? Because in many cases, if you're waiting on a network request to render data, there is an initial rendering pass that takes place in a component while you're waiting on that network request, while it's rendering, maybe your loading states or something like that. And you wouldn't want to say that the component is interactive when all you have is a loading state, right? So you need to build your architecture in a way that it can account for asynchronous behavior, whether it's network requests, images loading, or anything like that. The next thing you need to do, as I said, is you have this tree, so you need to not only capture per component events where you're saying, okay, the component is initializing at this timestamp, it's done rendering at this timestamp. You also need to be able to bubble that up through the tree so you can get a page level number as well. You want to be able to say each of my pages took this long to render because ultimately when you're doing analysis on this data, that's probably where you're going to start. You're going to say, okay, throughout my application, these pages are the slowest pages, and if they receive a lot of traffic, then that's where I need to start optimizing things. And honestly, you really should not just look at what is the slowest page, but really look at which pages are being visited by your users the most. So if you're thinking about how you want to approach the actual optimization, then you should really be looking at a traffic weighted approach to these different page level numbers. So in order to actually roll things up to a page level, you're going to need a way to tie your parents to their children. Different frameworks do this differently. Some are easier than others, but you're going to need a way to work up from the bottom of the tree to the top because you have your leaf components rendering first. Essentially, they're completing rendering first anyways. And so you need the leaf components to be able to tell the parents, hey, I'm done rendering. Now you can check to see if your components for interactivity have been fulfilled. And then ultimately, if you have complex conditions for interactivity, you're probably going to want a common interface with that, right? You're going to want to have your architecture to expect a method to be defined on your subscribers that can just be called to check if these conditions are done. And the way that we did that is, we just had a method that expected a Boolean to be returned where it was true if the component was interactive or false if not. And we actually passed in a method to this as a parameter where you could pass it the name of any component to check if that component was done rendering. And so, as a child reporter, when you report that you're interactive, we would just trigger this method on the parent subscriber, and we would just be able to say, hey, this is sort of a way for you to check your various conditions, and then you can check all the different components that you're waiting on, and if they're all done, then you return true, and now we know that you're done, and we can take the timestamps for that subscriber and keep rolling upwards. So how do we actually do this in different frameworks? Well, first of all, let's talk about React. I'm sure a few of you out there are using React. The best way to do this in React is to use the component did mount hook. So that is a lifecycle hook that gets invoked immediately after the component is mounted, which means that that sort of that first rendering pass has taken place. Architecturally, I would recommend creating a higher order component for this because you can encapsulate all of this latency tracking functionality in this higher order component and then wrap all of your other components in it in order to share that code. And then in terms of establishing that parent-child relationship, you can just use this.props.children, which gives access to the child components. So inside your HOC, you can actually just go in and pass a reference to yourself down to the children using the children prop. And then your children would then have a parent prop that they can use to say, hey, I'm done, go ahead and check your own conditions. If you're using Ember, it's going to look a little bit different. You're in Ember, you don't have everything as a component the way you do in React. So, you're going to have routes and components that you need to care about. When it comes to routes, the hook that you want is did transition. So, did transition just kind of does what it says, which is it fires right after a transition completes. And then for components, you have did insert element, which gets fired after the components element gets inserted into the DOM. Now, in Ember, these events are firing potentially before the first rendering pass has completed. So what you want to do is leverage Ember's run loop, and you can actually schedule a callback in the run loop for the after render event. And when the after render event fires, that's when you know that the run loop has completed one pass of rendering. So you know kind of the top level pieces of the template have been rendered, but not necessarily the children, since the children will take care of their own tracking. And then the parent-child relationship is pretty easy to establish because you have access to this .parent view as a direct reference to the parent. Now, for Ember, I wouldn't recommend going through and trying to build this all for yourself because I've actually published an open source add-on that does this for Ember apps just out of the box called Ember Interactivity. You can go check out a demo there if you want to check that out for your Ember apps. So if you're using Angular, it's going to be a little bit different. There are a lot of different hooks that you might think to use here, but the one that I would recommend is ng after content init. So that is a hook that gets called after Angular has fully initialized all of the content of the directive, but again, not necessarily the child views. And I believe that the best way you can establish this parent-child relationship here is doing view.component off of the parent injector, and then that will give you access to the component that you are a child of. Now, finally, if you're using Vue, this is a pretty obvious hook here, which is mounted. Gets called after the instance is mounted. It's a pretty good name. You might think to use this .next tick if you're familiar with that one, which actually gets called after all the children have been rendered. However, in this case, I wouldn't necessarily recommend it because that method gets called after literally everything below you in the tree has finished rendering. So if you're trying to think about the critical path of your components, then you're not going to really capture that, right? Because this isn't going to get called until everything that is a child of this component is done rendering. So if you think everything in your application is critical, then you could do this, I suppose. But I would say mounted is probably the more scalpel approach to be a little bit more accurate in your data. And then in this case, the parent-child relationship is pretty simple. Again, you can just access this .parent, and it's no problem at all. So if you have built out this architecture and you're instrumenting your application, it might be helpful to have some sort of developer tooling in place so that you could, be able to understand the performance impact of your application without having to go to your data scientist and ask for the analysis of the data that you're recording. It might also be useful to have tooling that allows you to do some active debugging of your application as well. So this is where I would recommend utilizing the Performance API. If you're not familiar with the Performance API, it's just an interface in the browser that allows you to track and access performance info for your application. I would start by using the method performance.mark, which will allow you to just create named timestamps in this performance buffer. So you can just create whatever timestamps you want. The way that we did it is, we would create a timestamp when a component begins initializing, and then we would create another timestamp when the rendering is finished. And then we can call performance.measure, which actually measures between the two timestamps so you can understand the duration of that rendering activity. All of the data in the Performance API can be inspected if you wanted to actually access the data in your code. You can send it off to any sort of tracking services that you might have, and you can actually use it for visualization, which is the cool thing that I want to talk about a little bit more. So Some of you may know that if you go into your DevTools, there's a performance tab where you can record a full page load, and it will actually record a lot of interesting data. So if you were to use the performance API and then go in and record a page load, you can actually get this really cool thing where those timestamps and the measurements that you took actually show up as user timings here in the output from your performance recording. And you can actually use this to get a full component waterfall of your application. So in this case, you can see pretty clearly that we have sort of our index route, and then we have sort of a first level component that is a child of the route. And that first level component has 3 children, one of which took a really long time to load, which then created a bottleneck on the rendering of the route itself. So this is just a really, really nice way to be able to allow your developers to debug the performance of their application and really utilize your architecture for multiple purposes. So another nice little bonus that you get out of this is that if you were to allow this performance API usage to be run in production as well, you can actually see all of these user-defined timestamp events in a third-party tool like WebPageTest. So WebPageTest, along the bottom here, you can actually see all of these individual events getting put in the report from WebPageTest, which actually highlights why I think you want to be using framework internals to do this instrumentation and not just rely on third-party tools, because you can see here that the load time that WebPageTest recorded was about 1.2 seconds, but we have components being initialized at about 1.85 seconds. So clearly, there was something going on here where WebPageTest thought that the page was done, but there was still work being done, and in this case, it was because there was an asynchronous request being made for data, and those components didn't get rendered until the data returned. So this is useful for being able to understand and better utilize the output from something like WebPageTest without getting inaccurate data. So ultimately, what did we actually learn from going through this process of architecting our front-end application? So, first of all, you definitely want to define the critical path. You want to understand what is actually the primary content of our page. And you probably, as developers, probably have a pretty decent idea of what that is. We definitely consulted our UX professionals to really understand from their perspective, like what do they think the user is coming to the page for. If you have the time and resources to do user studies and actually understand your user behavior on your site, that can be really helpful. But however you do it, you want to understand what are the components that actually are required to be rendered in order to call this page interactive. Because once you know that, then you can use this data to identify bottleneck components that are slowing down your page. And it also allows you to take on some interesting strategies like, hey, if I have secondary content on the page that is not really necessary for the page to be interactive, can I actually defer that rendering behavior, right? Can I just say, hey, don't even start rendering this component until the page is interactive because the user doesn't care. I'll just load it in the background once they're already using the page, and that can actually make your app more performant because you might be asking yourself, okay, well, if we're only instrumenting the critical components, what if there's some other component on the page that is impacting performance, and how do we track that? Well, the answer is you can instrument all of your components, even the secondary ones, and you can capture that per component data to know if a component is particularly slow, but those secondary components are not going to have a subscriber that's waiting on them. They're not going to have a parent that has them as part of their interactivity conditions. So at that point, you're just capturing the rendering duration of that component so that you have that data, but you're not rolling it up into the page level numbers. Now, ultimately, the thing that I really want to get across today is that if you are thinking about performance, you want to make sure that the metrics that you're tracking are user-centric, because you want to make sure that any optimization efforts that you invest in are actually having a positive impact on the user themselves. Otherwise, you're just going to end up taking on optimization without really knowing whether or not it's having an effect that is benefiting anyone. And this is why I think it's important to also understand traffic, right? Like if you have a slow page that only gets like 1% of your traffic, is that really something that's worth spending time on, right? Who actually cares if this one page is slow if no one ever actually visits it? You're better off improving a maybe slightly faster page to make it even faster if it has like 60% of your traffic. So how can you guys actually go and take this knowledge and move forward and take it back into your own applications? Well, first of all, I wouldn't say that the architecture that I'm recommending here is the end-all be-all. I think it is important to use multiple tools and approaches for instrumentation. I think that all of the third-party tools that I spoke about have uses. They're really good for just getting a lot of suggestions for optimization. I just wouldn't use their data for really digging in and trying to get sort of those granular optimization decisions. It's also, it's important to measure each layer of the stack. While user-centric metrics are going to give you a good idea of how the entire stack is impacting the user, that's not going to tell you like which of your microservices need improvement or where within that code you should improve things. So instrumenting the back end is just as important as instrumenting the front end. I wouldn't cast aside any of those approaches. But you do want to make sure that you understand the impact on your users. One of the things that people like to do when they're taking strategies similar to this is they might instrument their application and then run that instrumentation in a VM, because they're like, okay, this is a reproducible environment. We know all of the conditions of it. And that's great in some senses in terms of like being able to get some relative change over time. But it's really hard to simulate real world environments in a VM, because you're talking about, okay, users have a bunch of different devices that have different CPU powers. They're in different countries that have different network conditions. They might be using different browsers, and there's a really huge, matrix of all of these different possibilities. And if you're just running things in the VM, it's really hard to get an understanding of that. One of the most important things that we learned when we implemented this was that our performance in other countries, such as Brazil, was actually really poor. And so we actually had to make investments in beefing up our own networks and getting CDNs closer to the users so that we could improve the load times of our app in terms of just delivering them the assets. And that was a really big deal for us that I don't think we would have understood if we were just going into AWS or something and having them just run some VMs against our instrumentation. So ultimately, if you want to understand how to break down your front-end application, I highly recommend using framework-aware tools. If they don't exist, build them. And if you are building them, I highly recommend building them for open source, because I think we would all appreciate being able to share in the investment of building out tooling like this. So the last advice I would give is just, if you are taking on this challenge, be cognizant of the performance impact of any instrumentation that you build. One of the things that we really had to think about was, okay, we could have tapped directly into the rendering engine of our framework in order to understand exactly when render events were being fired, but that has a problem because any work that you're doing based on that event becomes render blocking JavaScript. And that will actually introduce performance overhead into your application. So that's why all of the suggestions I made here are lifecycle hooks that get fired after rendering completes. So it is sort of the closest approximation to the rendering times that you can get without actually having an impact on the application itself. So just be wary of that, because if you are going to run this in production to get user data, you don't want your instrumentation to actually make your application slower, or you've kind of defeated the purpose. The other thing I would say there is, because we're running this instrumentation in production, we're not running it for all of our users. If you have millions of users using your site daily, you don't want to be capturing individual component events for every single user you have, or you're going to overload any analytics service that you have. Running analysis against that is just going to take forever. So I would just be cognizant of thinking about how many users you have and whether it makes sense to do like 5% of users in production or 20% or whatever, depending on what the scale of your application is. So that's everything I had today. I really appreciate you all being here. My name is Jordan Hawker. You can find me on Twitter, GitHub, or my website. And if you want to check out the slides from today, you can go to jhawk.co/RVA-18-latency. Thank you all very much. If anyone has any questions, feel free to ask. But I hope you all have an amazing rest of the day and enjoy your lunch. Yeah?
What are your thoughts on server-side rendering and also second question, lazy loading?
Sure. So the question was like, what are my thoughts on server-side rendering and lazy loading? I think server-side rendering is actually really important. I think it is part of solving this problem. I think if you don't think so? No. I mean, I think that if you take on a server-side rendering approach, you can deliver to the user, some of the content already rendered for them, which is going to reduce the amount of time that they have to wait to actually feel like the application is interactive. Now, it kind of depends on what the server-side rendering solution for your particular framework is. Some are a little bit easier to work with than others, but I think that as a concept, there's a lot of value to it. In terms of lazy loading, that's kind of a generic term, so I'm not sure exactly what you're referring to.
Like basically loading the stuff above the fold and as users scroll down loading.
Yeah.
Instead of loading it all.
Right. Yeah. No, I think it's definitely valuable to optimize loading what is visible in the page, and then lazy loading other content. One of the challenges that we had in building out this architecture was we would have pages where we would have like just tons and tons of data being looped through that we were rendering on the page, and as you said, like only some of it is above the fold. So we actually built the architecture to allow us to specify a number of components that we were expecting to be rendered in the case where our template was just a loop over data rendering the same component over and over again. So we would try to approximate how many components would be visible above the fold, and then say that the page or the parent component was interactive when that many components were rendered, so that we would not wait for all of the other components to finish rendering and could have our optimizations be really focusing on what's visible. So yeah, great question. Yeah?
So let's say you start instrumenting everything.
Mm-hmm.
There's got to be a lot of infrastructure involved in actually like collecting, aggregating, and analyzing that. Can you just speak into some general ways, some tools or services or techniques around that process?
Sure. So the question is, if you're building out this architecture, there's a lot of infrastructure that you have to think about in terms of like collecting and analyzing this data, and like what strategies are there. In many cases, you might already have a way to do this, but there are a lot of companies out there that provide analytics services. Google Analytics is one that most people have heard of. We used Mixpanel for a really long time, which is another great example. That's actually what I use for my personal website, because they have a really nice free plan. But ultimately, you want to make sure that any data that you're collecting in your application, you are building out enough data to understand what the component was and what the duration of rendering was and any other application-specific information. And then you do want to be sending that off to some sort of service that's going to collect that data and allow you to analyze it. Thanks very much, everyone.